hydrogen and of carbon present in 1.3 grams of X are determined by passing its combustion products to the
Which question are you reading?
2A.
So this question is about two organic compounds X and Y. Both are liquids which contain carbon, hydrogen, and oxygen. They must be either alkanos or alkanoic acids, isn't it?
I mean, they can be alkenes and alkanes.
Do alkanes have oxygen?
Oh, okay.
Alkanes are hydrocarbons. They only contain carbon and hydrogen. So they're either alkanos or alkanoic acids. So the mass of hydrogen and of carbon present in 1.33 grams of X were determined by passing its combustion products through the apparatus shown.
So the 1.33 grams.
1.33 grams.
The experiment.
No, the 1.33 grams was the amount of X that underwent combustion in the presence of oxygen. They are passing pure oxygen through that combustion tube. The heating gets done. They place 1.33 grams of X inside that combustion tube.
1.33 was determined by passing its combustion through them. Okay.
Do you know that X is an organic compound, Y is an organic compound. Is that okay? X is an organic compound containing carbon, hydrogen, and oxygen. They place that X into that combustion tube. The mass of X is 1.33 grams. It is 1.33 grams of X that undergoes combustion.
The mass of X is 1.33 grams.
Yes.
And it's 1.33 grams that undergoes combustion.
Yes.
So
In the presence of oxygen. Yes.
The whole thing undergoes combustion.
Yes. So on undergoing combustion, if it is actually a compound containing carbon, hydrogen, and oxygen, it can only be able to form two products. That is carbon dioxide and water. You are getting it? And of course, if you look at the two U-tubes, isn't it? They have silica gel. A silica gel sometimes even gets placed in the clothes to absorb moisture from the environment. So that absorbs moisture and that absorbs carbon dioxide. Soda lime, that is sodium hydroxide and calcium oxide, a mixture. So the excess oxygen gets removed because they are passing some oxygen inside this tube, isn't it? So they want to remove the excess oxygen so that it does not interfere with the values that you actually end up getting when you measure the amount of the CO2 and the oxygen in these cases. Yeah. So state the measurement that should be made, the measurement for water and CO2, isn't it?
Oh, so it's 0.
Yes? 0?
Yeah.
Look at this man. We have two organic compounds, X and Y.
Yeah.
These two compounds are organic compounds containing carbon, hydrogen, and oxygen.
Yeah.
You're getting the point? And they are allowing these compounds to undergo combustion. The first compound you have begun with is X. X contains 1.33 grams, which can either be C6, H12, or 3. It has to have all the three elements, carbon, hydrogen, and oxygen. So they pass oxygen through this combustion tube because this compound can only undergo combustion under the presence of oxygen because oxygen supports combustion. So it undergoes combustion to form obviously two major products, that is carbon dioxide and water. These people, they are saying the mass of hydrogen of carbon. So they are interested in determining the mass of hydrogen and carbon. But you cannot get the literal mass of carbon and hydrogen in this compound. We must first get the mass of carbon dioxide and water. And then that can help us to get the mass of carbon and hydrogen in the two different compounds. Can you take a compound, then extract carbon and hydrogen, and then measure their masses? So you must first allow that compound, for example, to undergo combustion.
So state the measurements that should be made.
You can take the measurement of the U-tube with its contents. Because you're interested in getting the mass of water and CO2. Yeah. But you can't extract again the water from that case, then be able to measure its mass.
So you can just measure like the weight of the silica gel.
The mass or weight of the U-tube and their contents. You see? The mass or the weight of each U-tube and their contents.
Notice the mass of the contents of the U-tube.
Yes?
Why would we want to measure the mass of the U-tube? Why not the mass of the contents of the U-tube?
You see, there's something you need to understand here. This is the U-tube, isn't it? It contains what? The silica gel and the gas.
And the water.
So I'll first take this U-tube and the silica gel, I measure its mass. Okay? Then after that, I again allow now the reaction to occur. Obviously the silica gel absorbs what? The water. The mass has to increase. Then I finally measure now the mass of the U-tube and its contents after. So first, I measure the mass or weight of each U-tube and their contents. Okay?
Mass of each YouTube
and each, yeah, mass of each YouTube and their contents. Then you can again take the mass or weight before and after combustion, isn't it?
mass of what? The X or the YouTube? Again.
Mass of the YouTube before and after the combustion of the experiment.
Yeah.
But you're not getting the point.
I am. That's why we started with mass of each YouTube and their contents.
I know the mass of YouTube and its content, isn't it?
So mass of each YouTube and their contents before combustion.
Yes. Then now after combustion.
Yeah. And then subtract.
Yeah, to get the mass or weight of water and CO2 absorbed.
Yeah, subtract to get the mass of water and CO2 absorbed.
Mass of, or the weight of water and CO2 that gets absorbed or produced, isn't it? And the next question says, give 2 reasons why pure oxygen and not air should be used to exclude the presence of water and CO2, isn't it?
As in, why?
Now, if you use air,
Yeah,
it will come with CO2 and water. It might interfere with our results.
Okay.
So we have to ensure that the oxygen we are using has an excluded percentage of carbon dioxide that forms part of the air and the excluded water vapor.
So to exclude CO2 and water.
To exclude water from the air,
Yeah.
and to exclude carbon dioxide from the air. Because air is a mixture of gases. What are the components of air? Carbon dioxide, water or moisture, nitrogen, oxygen, dust particles, you see. And again, if you're using impure air, the impure or the air has a mixture of gases, and one of the gases is nitrogen.
Yeah.
Nitrogen may slow down the rate of combustion. So for complete combustion, you may want to actually use pure oxygen, not the one found in the air. Air is a mixture. It has other components that do not actually support combustion. So that may later not actually allow this compound to completely undergo what you call combustion. So we may tentatively be able to actually use oxygen, which is in pure form, isn't it? To ensure there's complete what? Combustion. Or you can even say to ensure X is fully combusted. The purity of a substance in chemistry is very important, isn't it? It actually ensures that a reaction can occur completely and the final products can get recorded accurately, you see, to avoid any irregularity.
Combustion is slowed down. See, the product is still like.
Do you know why? Do you know why Allah decided that we have air and not oxygen, like purely in the atmosphere or in the environment? Because if we could be having only oxygen in the environment, then the rate at which combustion would be occurring. There's a fire outbreak in the adjacent building and everything gets burned here within seconds.
Wow.
So air being a mixture, it slows down the rate of combustion. You see, because we have components of air that do not support combustion, like nitrogen, the inert part of the air. We have carbon dioxide that can be able to put off the fire. You see. So they're saying the experiment
showed that 1.33 grams of X contains 0.14 grams of hydrogen and 0.63 grams of carbon.
calculate the empirical formula of X using the data. You must show you're working. That is very easy, isn't it?
I also add oxygen, yeah?
Yeah, you have to get the mass of oxygen. Add the two, get from the whole mass. You gotten the answer?
When they say empirical formula, doesn't really mind. C4H10, C4H10O.
What do you get as the mass of oxygen?
0.23.
Not 0.56.
0.14 plus 0.63 minus
1.33.
Oh yeah, 0.56. Why is it 0.56?